Hello, good morning, everybody. I'm Mauro De Barba from Eliwell by Schneider Electric. I'm here to introduce you a topic, just introduce in 10 minutes, let's say, about efficiency with digital solution in both commercial and industrial refrigeration. I say those topics are quite connected because refrigeration is a big topic in terms of energy efficiency, and both environment, let's say commercial, supermarket, but also warehouses and industrial environment are quite interested about the efficiency due to the refrigeration impact. I start just pointing some two concepts. One is about the need of efficiency and the way the efficiency can be achieved. So the higher we go in the sharing of information, so from the open protocols at the field levels or IT versus operational technology integration, I mean PLC speaking with the ERP local to the system or to different local system like BMS or SCADA system into an industrial environment, up to higher level of integration where we go to cloud or multi-site integration, so the possibility to compare and to analyze data coming from multiple sites. So the higher we go, the higher efficiency we can achieve. Unfortunately, in order to go up in the level, even if the higher we go, so the internet connectivity is easier than the field bus connectivity, we need to cover all the level. So typically the complexity starts from the bottom. So integrating controls into system and then system into larger multi-domain system and therefore into multi-site system. So complexity is based on typically the connectivity, and the connectivity has an overload, I would say, of complexity starting from the bottom. But as far as we are capable to simplify this complexity, we are able to achieve a higher level of efficiency thanks to integration at a higher level. I just put some of the potential at the various levels in terms of efficiency. That is not typically just switching off the loads in order to consume less or reducing the loads by using modulation, something we do into the machine typically. But it is also something we can do having modulation based on an entire system. I make just an example. Into our system, you may have floating suction control into a compressor rack based on the loads. So having an integration between the loads and the compressor rack at the system, refrigeration system level is a way to make a certain level of efficiency. Obviously, if we go up one level, like in the integration with different systems, like having the BMS managing the humidity into the environment, into the supermarket, we can reduce defrosts. We can reduce the needs for defrost. So we can balance the power used into the refrigeration system, the defrost system, or the interval and the duration of the defrost versus the power used into the HVAC system. And if we go up one level, we may have information that comes from the environment. So IT-OT integration means, for example, having information coming from the weather forecast in order to understand the humidity that we will have today. So we use better the information about the HVAC, and therefore we can have an impact on the refrigeration. Those are just examples of the integration of various systems in the energy management. But there is another topic that I think is enough important to be considered, that is about the maintenance. So the higher we go in the integration, more we are capable to do a better maintenance. So, or to optimize maintenance. And maintenance means that we manage the wearing of the system. So we have a reduction typically in the performance for mechanical reason, dust on the condenser, just to be simple, but we may have loss of performances, for example, because we don't adapt to climate variation, for example. So our system can be better adapted to the new condition that we have because we have much hotter summer and our system was designed for less hotter summer. So all this information, if it can be gathered and compared and reused to act on the system, enable a better efficiency. Maintenance efficiency means also not wasting gasoline with the car to go and fix the problem when it is possible to do it from remote, or let's say any type of efficiency like detective preventively the problem or in advance before the problem becomes too dangerous for the system. So all those are ways to create efficiency into a system, and typically the higher we go into the integration, the more efficiency we can produce. We have to consider that different system has different type of needs anyway, because we may have sites that works on demand. I mean, typically small retail stores just call the technician when there is a problem. So typically they just look for the problem, they call, and then it will be fixed. In a larger system, especially supermarket or industrial application, there is more a tendency to look for preventive maintenance and to have information in order to act in advance. But in the same way, different kind of situation may need different type of integration, because a supermarket may use the data into the ERP to compare with the sales in order to understand where it is more convenient to invest for fresh food, frozen food, and so on. So there is a different type of use of data depending on the type of customer. Supermarket typically goes into the building management for the comfort of the customer into the building, while if we go into an industrial site, the machine for refrigeration will be for sure integrated into the SCADA system for a better integration on the process. So there are different protocols, different architecture to be considered when we think about efficiency into refrigeration. The refrigeration is everywhere, and there are different conditions depending on the case. I highlight one point that is, I would say, the two pain points that we see today when we try to provide efficiency are summarized by these two icons. So one is the ease of use and installation, and the other is the cybersecurity. So I was saying that the higher we go in the integration, so more communication we put into our system, more we are capable to deliver efficiency. But as soon as we increase the connectivity, typically we increase the complexity to do it or to set up it. We meet more people, IT people at various levels, and we need to deal with very different skill sets. So we start from the technician of the refrigerator, the machine. We meet the IT guy, we need the facility manager sometime, or IT department of the headquarters of a supermarket chain or an industry. So being able to speak their voice and to give them the solution they expect is very key. On the other side, cybersecurity today is a concern. The more we go into large organization, large industry, industrial site especially, cybersecurity is a must. New regulation needs to, and the CRA Act are coming or are already a reality. And so the basic need for cybersecurity are really very high and typically cannot be handled by a refrigeration technician. So we need to be able to provide solutions that are ready to be used, that are thought with cybersecurity in the design of the product, in the design of the solutions. The various situations that we have seen before, I tried to summarize around our product that are available with the LUL brand, starting from the bottom. So sometimes we try to give a solution that is overloaded, let's say, and then introduce more complexity, more need for cybersecurity than needed. So if the need is just data logging, and here I'm speaking about small stores where we have a refrigerated unit and so on, we may just need a solution where the cybersecurity is embedded in the solution. And simple enough, mobile smartphone app, and it provides exactly what the customer needs. So HACCP compliance, so data logging, typically of the temperature, is the need. If this is the need, a solution that is simple, local, not connected, could be exactly the solution that is embedding simplicity and cybersecurity. We rise to a different level. We were saying that if we want to have efficiency, we need to step up and let the system communicate wider. In the previous example, we just had the data. So HACCP data means we have data we can analyze locally just for one site, just for one machine. If you go up one step, maybe we want to be advised, at least if there is a problem, if we have set a threshold for managing a problem. So in this case, we may have a system that is easily connectable. Wi-Fi is the way you may easily find into a small store. Bluetooth is a way to use an app and configure easily a device, because everybody can play with an app. And cybersecurity is managed by the app and together for the connection of your mobile phone to the device, and for the device to speak with the cloud, and for the cloud to deliver you the information. So having an app that raises a pop-up when there is a problem in your site is an advantage, because you can be not proactive, but at least intervene immediately when there is a problem. This could be a problem of temperature, of a compressor broken, of a sensor that is broken, and so on. And again, with the same tool, you can intervene locally via Bluetooth without any issue in terms of security, but also from remote. So this means that you may know exactly in advance which is the detail of the problem, bring with you the fan or bring with you the tools that are more suited to fix the problem. So this is a level of information that is not yet proactive, but it is so simple that it is applicable to a large number of applications and provides remote access without any configuration almost. If we go up one level, we may have a bit more complex system. Could be a complex machine with energy metering, some refrigeration control, valve drivers, and so on, up to 10 controllers, let's say. So a very small site or a large machine, would say. And here I really care about the same topic we have seen before. So I need to be advised, but I need, for example, to keep this machine within the organization. We are speaking about the solution we were speaking before with the cloud server. That means data goes out in a secure way. Eliwell Schneider manages the security of your connection, but obviously the data goes out. In the configuration we have seen before, we have customer not willing to let the data go out of the system. This is the case of supermarket chain, but could be the case of an industrial site. So in that case, using an edge device with connectivity capability, with an embedded solution, with web services and web-based user interface with secure protocol, is a way to have a full, easy to play and to connect interface that provide the food alert, that provide data, and that shares data within the network of the customer. In this case, we achieve a better solution because we can share data and have other systems like the HVAC system, the BMS system, taking care about the integration of the solution. here I'm speaking just about the refrigeration. Consider that Halliwell, part of Schneider Group, so with Schneider is capable to deliver the upper level, both the SCADA side or the BMS side for the integration of all domains in the store, in the building and outside the building. Moreover, if we go one step ahead, we may have another way to get and to improve the efficiency. Here we are looking at the edge that is bigger in terms of number of points, but I won't focus much on the number of points. I would focus more into the orange lines, so the capability to execute algorithms, PLC application, generally speaking. That means on top of all what we have seen before, that enable to be advised, that enable to intervene easily on the plant, you may have algorithms that takes into account the data that we analyzed, that is shared with other system, and that acts. I make an example, as I was saying before, it could be acting on the control side, like floating the suction pressure in the compressor rack based on the current load, current information coming from the field or from outside. But could be also algorithms that analyze the data and provides alerts in advance. I make an example that is very widely used in South Africa by our customer, that is because energy is so available with some losses sometime. There are some energy leaks, let's say. They need to control very much the peaks or the shapes of their loads. So analyzing the shapes of energy consumption of the machine is something that the edge can do, based on the data collected before, collected centrally, collected at an higher level, but can be acted locally. So even if connectivity drops, the algorithm runs in the site based on general data collected generally, but drawing a shape that is the best shape not to go above the maximum consumption limit or the availability from the network. So this is something that can act on the loads, so changing the set point, putting in energy saving mode some non-critical equipment, or just alerting in case the system is going out of the boundaries that are set. So this is very important, and together with the integration into the EMS, energy management system, building management system, or SCADA in case of an industrial site, enable to let the data flow easily with secure protocol and let the system be independent to act based on the data. So could be something that is predefined, or could be something that is modified over the time thanks to the data that is collected centrally or multi-site. Just to summarize, so just to give you an overview of our offer, we go from a solution that is pure data collection to let the simple, small application be visible and understood in terms of consumption, in terms of profile of usage, with a simple local Bluetooth connectivity, going through a simple to set up connectivity to the cloud to collect data and to act from remote for very small sites. So super easy for the installer to be set up with what is really necessary. So data coming in, easy to analyze data, and possibility to interact with the machines, up to systems that are more, let's say, open, configurable. Obviously, here we enter into more a system integration level, where the extra functionality enable a large way to share data in the site, in the field bus, in the site, and to the upper level multi-site. And to act, so not closed system, but open system with open protocols and open programming language that are used, to provide the efficiency algorithm in the site. Thank you for attending. If you have any question, I'm open to answer. Any? Yes. Yes, please.
Mike?
Yes. Yes.
Hi, thanks for the presentation. Maybe just one question. Can you interface with other manufacturers' controllers too? In the highest version, the Televis 10 version?
Thank you. Thank you for the question. Yes, if we look today, the two highest level model, we have open protocol and we have also what we call open driver. So actually it is possible to write the description of the controller, whatever it is, either an energy meter, an HVAC controller, refrigeration controller, in order to be represented and managed by the system. So real-time values, parameter, commands, whatever are categorized, can be written into a file that is compiled and fed to the system. And this could be done by the user itself. There are some rules and a compiler that checks validity of this data. Okay, they are cutting my time. If you have more questions, just come to Honeywell booth eventually in Hall 5. Thank you very much again. Thank you very much.